What is N-type semiconductor? What is N-type? What is conducting electricity in an N-type semiconductor? Electrons. Okay. Okay, great. So for an N-type semiconductor, we have electrons that are freely moving. They're freely moving around. And since our semiconductor are always electrically neutral, so we also have positive charges in N-type. So these are fixed charges. They don't move around. So in N-type, we have freely moving electrons and fixed positive charges. And P-type is the opposite. So what is conducting electricity in P-type?
Holes.
Holes. Okay. If this is something new to you, so holes are conducting electricity in P-type, and they have fixed negative charges. Then the question here is, what happens when we stick an N and a P-type semiconductor together? What happens when we stick them together? The holes and the electrons are freely moving around. They may meet each other. What happens when they meet each other? Oh, yeah, they combine. So that's a process called recombination. An electron meet a hole, then they recombine and disappear. So by putting a P and N-type semiconductor together, so the holes and electrons will recombine and disappear. So that leaves behind fixed negative charges and positive charges. So we have fixed negative charges on the left and the fixed positive charges on the right. So that creates a field. You agree with me? That creates a field. That is called a built-in potential. And the region here is the depletion region. So what happens in an LED is that we apply a voltage to the LED that we are forcing additional holes and electrons into this depletion region. Then what happens again?
Recombination.
Recombination again. Then they recombine and they release energy by light or by photons. So that's how LEDs work. And the color or the wavelength of the light they generate is dependent on something called energy band gap. And this is the property of semiconductors. So depending on what semiconductors we use, we generate light of different wavelengths. So we have many different semiconductors, and that generate light of different colors. So actually, LEDs won a Nobel Prize because they were able to find a semiconductor that generates blue light efficiently. So building LEDs really is essentially finding the semiconductor material. All right. So again, LEDs are essentially diodes. So here I have a typical IV curve of a diode. So when we apply voltage, when we apply a bias, the current grows exponentially. And in your data sheet, they also often provide a parameter called